A new strain of macOS malware that spies on compromised users has been discovered in the wild. This new malware also exclusively uses public cloud storage services to communicate back and forth with its operators, as well as exfiltrate the victim's personal data, keystrokes, screen captures, microcordings, and so on. The breakdown of this malware comes from We Live Security, and a link to the full article is included in the description of this video. So CloudMensis is developed in Objective-C, which was most commonly used for development on Apple platforms before the creation of the Swift programming language. The samples that have been found are compiled both for the older Intel and the newer Apple M1 architectures. So simply having a newer MacBook, it doesn't automatically protect you from this. Also, the initial attack vector is still unknown, so I can't simply tell you to just update or stop using a vulnerable program to be completely immune to this. But there's only a handful of people that have been compromised by this malware since the beginning of this year, so it's believed that CloudMensis is really just targeting specific people and it's not trying to compromise a whole bunch of machines. And if that is the case, then there could be a number of different attack vectors for the different victims, depending on how much reconnaissance the hackers are doing before starting the exploitation. So when the malware is executed on a victim's machine, the initial payload that runs, which the malware authors probably called execute based on the samples examined here, has a pretty small footprint, likely so that it can avoid detection, so that things like antivirus programs won't pick it up. And all that the initial payload really does is escalate privileges to root access, which I know all it does, but it's necessary for it to gain root access for the rest of the malware to do its thing. And upon doing this, it also downloads the second stage payload called client from one of many different cloud storage providers. But unlike a lot of other malware that we've looked at in the past, this one does not use a publicly accessible link to serve the second stage payload. Normally, hackers would take over someone else's web server, and they use that as the command and control center. They use that to serve additional malware because the technique of using a really small and simple executable file as the initial payload is pretty common, but then it usually ends up connecting to some kind of website or some kind of web server that the hackers had previously compromised. And when that happens, once the administrators of that website manage to get their control back, that's one way that they can end up shutting out the hackers, or those particular websites and access to those IP addresses can be blocked. Another way, which would block the hackers from being able to communicate with the malware. But CloudMensis is using private links to these cloud servers, and then it's using an access token to actually gain access to them and download the rest of the malware from a private cloud link. So it's a lot harder to block it. And pCloud was one of the providers that was being used to host the second stage malware in this case. So, like I said, the second stage spy agent, that's where the real magic happens. So it stores its configuration in a file that's almost 15,000 bytes in length, called com.apple.itunesinfo29. The malware also keeps backup configurations in a file called com.apple.itunesinfo28 and com.apple.itunesinfo. And these configuration files, they contain things like which cloud storage providers to use, a bot identifier string, information about the Mac that has been exploited, paths to various directories that are used by CloudMensis, and file extensions that the hackers are interested in looking for, the data that they want to exfiltrate, which seems to mostly be personal file types like documents, spreadsheets, pictures, and audio recordings. The malware also encrypts its configuration files with a custom function called flow encrypt. And here is a chart of the disassembled function, which takes a single byte as a seed and it generates the rest of the key by performing a series of operations on the most recently generated byte. Now, in addition to stealing a wide array of files from the victim's Mac, the malware is also able to capture the screen and record the victim's microphone and record them through the webcam. But normally, these kinds of things are not possible to do on macOS 10.14 and later without notifying the user because of Apple's transparency, consent, and control. Basically, that feature generates a prompt that the user has to accept to allow access whenever a program needs to record the screen or your microphone, or whenever you need to allow access to external devices like a flash drive. But the malware is able to get around this by first creating a new database where the spyware is whitelisted, so it's allowed to do all these different things. And then it sets the home environment variable to the directory of the new database using launchctl setNv, so that when the TCC daemon is reloaded, the alternate database where the spyware is whitelisted as if the user has said that it can run and don't ask me again for permission when it wants to run, that one is loaded. So then it's just able to go ahead without raising those prompts. CloudMensis comes with tokens to talk to other cloud providers like Dropbox and Yandex Disk, in addition to pCloud. And it oftentimes switches between cloud providers that it's talking to depending on which function it's going to be running. One of the functions called CloudCMD is used to hold commands transmitted to the bots. Another one called Cloud Data is used to exfiltrate information from the compromised Mac to the cloud host, and Cloud Shell is used for storing shell command output. Now, when CloudMensis is communicating back to its CNCs, it uploads RSA encrypted reports about the compromised Mac on CloudCMD. And then to retrieve the commands that it's going to run on the Mac, it downloads an encrypted file containing those commands using CloudCMD. And for the larger data exfiltration, the malware just uploads an encrypted zip file to the cloud. So the developer is definitely taking some steps here to hide their intrusion and possibly obfuscate what data it's collecting exactly. And this is further confirmed by metadata that was obtained from one of CloudMensis's cloud storages, which reveals that the pCloud accounts were first registered in January of this year, and then Macs were being exploited as early as February of this year. Here's a chart detailing how many machines were compromised from February to the end of April. So this is something that's been going on for several months, and again, only a handful of machines are being compromised, indicating that it's probably a targeted attack. Now, as far as mitigation goes, like I said, initial attack vector is unknown, but since it does appear to be targeted attacks, it's just very unlikely that you're even going to randomly encounter this malware in the first place. However, the function of the malware that bypasses TCC relies on a macOS vulnerability that was patched back in 2020. So if your machine is up to date and you happen to be on this hacker's hit list, then at the very least, they won't be able to exfiltrate your data or listen to you through the microphone or watch through the webcam and things like that, at least not without you getting that prompt to allow it. And now that you know about this malware, you can also take steps to see if its configuration files are on your system in the first place, and you can remove them to effectively disable it. And hopefully this malware analysis shows you that just because you're using a Mac, you shouldn't lower your guard. Malware infections are still possible, and it's always important to practice good OPSEC. Like and comment to hack the algorithm, follow me on Odyssey, and have a great day.